It's the number of people that they're answering. Now, for some reason in this course, they get really caught up in notation, and you might think, well, is it big N or is it little n? It is little n. And I don't have a great explanation for that, but this particular class is very picky on, is it capital letter, not capital letter, Greek letter, not Greek letter. I'll try to clarify some of that, but it's not as intuitive as you might think here.
Okay.
Right. So the important thing here is to keep in mind that the numbers they're giving you, they're either from a sample or population. Now, because they started out by saying 60 students, you know that all the following values are a sample. So this 2.06 is a sample mean or average.
Mm-hmm.
And you know that because they're saying of the 60 students, they're not saying something else. This one's very specific. This is good to hear. And the variable is x bar referring to that horizontal line up top.
Okay.
Is that okay so far?
Yeah.
And then standard deviation, 0.42. It's the sample standard deviation, and they use lowercase s for that.
Okay.
And that's it. Like, instructor's not looking for anything more than that. They are grading you on the word sample or population. Sometimes they're very particular about how you spell words. You have to get the variable right. We can make a chart here if we missed out on some, but any questions on that?
No, it makes sense.
Okay. All right. So it looks like you've already done number 3. Do you feel confident in your work?
Yes.
Yeah, it looks pretty good from what I'm seeing here. So it says, of the 250 residents of an apartment complex. Now there's a little bit of like you having to decide if that's everyone in the apartment complex. It actually
Mhm.
seems kind of small, but the way it's written, it is everyone. When you actually start thinking about how many people live in an apartment complex, you're like, wow, that's a lot of people in such a small area. But
Mhm.
the fact that you see 14%, generally percentages are used for proportions, and you do say that down here. 20 residents were surveyed. That sounds like a sample of people that were surveyed, and 17%, oh, that's another proportion, and so on. So 250 is the population size. That's everyone. That's everyone.
Mhm.
Capital N, very important there. Population proportion. So they never use the percentages. They're always decimals. So this population proportion is p, little p. And then sample size is little n, lowercase n. Sometimes we say little n. 0.17 sample proportion, p hat. Good. Maybe it kind of looks like a hat. No. 0.83. So this is so you might have to differentiate between sample proportion. Like somehow you want to differentiate between like the favorable and then the unfavorable, between the 0.17 and the 0.83. I'm not sure how your instructor, is this what he or she used?
Yeah, but it's kind of confusing.
Okay. Like normally you just talk about p hat. You don't talk about the let me get the right word here. Complement. So this 1 minus p hat is complement. And like I think of p hat as like, well, we gotta be careful here, but like it's like either the light is on, and then 1 minus p hat, the light is not on. So I think of it as like the thing that you're of interest. I'll even maybe write that word here. But you have to give it some context. So it's like it's the sample proportion that read books. So you would actually want to maybe say that here. That read books, that maybe even say regularly read books. I think your instructor wants you to be that explicit. here.
Okay.
But you could also say, well, am I being descriptive enough in this population size? Well, maybe. So there's people who write papers and they would obviously give more of a description of this. They would say that it was an apartment complex in this side of town and it was this type of buildings and there were 1 bedrooms and 2 bedrooms. We don't know all that. We just know that it's an apartment complex. This is probably sufficient, but because we've got 2 related numbers, you might want to, like you did here, differentiate between them. And
Okay.
I'm not being picky on you, but keep in mind, like, it's not that they're non-readers. It's that they don't read books. And it's like a small distinction, but this class is in the gray zone of math. It's not like solving for X. There's a little bit more left up to interpretation. It's like a non-reader could mean something than someone who does not regularly read books.
Okay.
So just keep that in mind. But this is great. This is totally great. And I think you understand this. Should we
Yeah.
do 4 and 5? Or I guess 4, you got to make one up. Do you still need to do that?
Um, yeah, could we do 5?
Yes.
Okay.
It's always good to try to pick something that you already know. And I know you swim. I don't know what else other interests you have other than that, but it's always good to pick like something that's meaningful to you. So this 100 here means that there's 100 people in the population. That'll be easy to come up with, but the mean is 4.1 centimeters. So that's like measuring something. And like for reference, 2.54 centimeters is about 1 inch. That's from so 4.1 centimeters is like 1.5 inches. So it's not very big. So what is something that you might measure that would be around that length? And food, think of food. Maybe food's sometimes a good one to reference.
Maybe like a stick of gum.
Okay. So that's we would say we can put that in here, but this is the population mean. And we know that because of the mu. And then the next one here is the population standard deviation because of the sigma. We'll get to the example, but it's good. It's good that you said some gum or anything that is reasonable here. The 100 is the population size. And we know that because of the N, the big N. Sample size is little n, sample mean is X bar, sample standard deviation is S. Okay, so now your scenario is that you sample 60 people out of like 100 total, and or 100 packages of gum, for example. Okay, so like you can keep it pretty simple, but it could be like let me type this. 100 packages of gum were left behind. It doesn't have to be super complicated after we don't need to be we don't have to be very specific, do we? I mean, is that good enough, or do we have to be more?
It's okay.
Okay, I mean,
That's fine.
Thinking like a convenience store, and I don't know, but okay. The brand is known to have. So when you say the word known, that means like it's assumed to be true. Known to have a mean. Sorry, I'll do that. known to have a mean length of 4.1 centimeters. Per stick, something like that. It is also known to have 0.4 centimeters standard deviation. So by using this word known, we're saying this is what's true. What's like
Okay.
accepted, or accepted is another word you might use. The instructor's looking for that word known. They want you to differentiate between population and sample size, but you can't say population. You have to say like known or assumed or believed, like it's some sort of synonym of that.
Okay.
Okay. So now next is to talk about the sample, but you don't want to say the sample. I mean, you want to be, when you write, you always try to find better words than the most obvious one. So you might say 60 sticks were randomly chosen and measured for their length. Yeah, it doesn't need to be complicated. Now we didn't come up with that value, but we need to give it like, and it could be anything. It could be like 4.15 or 4.2. It really doesn't matter. I'm not using all the best words here, but and found to be 4.15 centimeters. Units are very important here also. Make sure you get the right units in there. And then you can go on to say with standard deviation, and just pick numbers near the ones that are given. You don't have to get too complicated with that. When you're doing an exercise like this, it needs to be believable.
Okay.
So your gum example is a good one. Length of a French fry. But some context, right? Like if it's 4.1 miles, that's different than centimeters. Like you gotta, that would be like maybe the length of someone's property. Try to make it something that you reasonably are comfortable with. And not too specific either. Don't be like, well, it's this one swimming thing that we do this one time that nobody knows about, because then they got to look it up and you're making work for your so there's that. Okay, do we need to do 4, or do you think you can, do you think it's clear? Do you want us to come up with something?
I think I'm good. Can we move on to the other worksheet, checking out components, please?
Yes. So I see a bunch of problems on here, 469 through 476. Which one should we start with?
Let's see. Could we start with 471?
Yes. This is a classic exam question. Okay, how will the confidence interval be affected if the confidence level increases from 95% to 98%? Okay, so the answer is simple, is it gets wider. Okay, and you just have to know this. Now here's why. It gets wider because to be more certain, you need to include a larger range of values. Okay, and what that means is if you can't sample everyone, if you increase the confidence interval, you have more confidence, for lack of a better word, that you've got it right. So these are kind of like flashcards. It's like increase confidence level. Do you guys use confidence level or confidence? I guess that's what you guys are using. Increase confidence level wider. So this is like a note card, first side, the other side. Similarly, if you decrease the confidence level, it gets narrower. You can think of it as another way to think of this as if you were to look at the numbers from 0 to 100, and if you were to go from say 2.5 to 97.5 versus going from 1 to 99, which is wider.
So 0 to 2.5.
So this is the 95% one, and this is the 98% one.
So which one has a wider range?
Yeah, which one's physically wider?
The 98%.
That's right. So if the visual is better for you, that's another way to do it.
Okay.
But that doesn't work for everything, but it works for this one.
Okay.
We should maybe do 474, 475 next, just
Okay.
because they're related. There are other things here. I can cover them all if needed, but the sample size. So the sample size, let me do it this way. As the sample size increases, okay, the confidence interval, okay, so the window, this actually decreases the width. So maybe we should say narrower. That's probably better. Let's use increases instead of this. The confidence interval becomes narrower. And you might, see, whenever they're kind of opposite, that doesn't always make sense intuitively. The idea is that the more people you sample, the better representation of the population you have. So you have a better idea of what people are telling you is actually true. And that's why it narrows down, because the narrowness of it helps you to say it's just this group that's in between these two numbers rather than the more numbers because we haven't sampled enough people. And so similarly, as the sample size decreases, and that's what you said here in 474, the confidence interval widens.
Okay.
And then they use this term in economics, ceteris paribus, but it's all things being equal. Like it's like what we just said is true if this is the only thing that's changing. If there's like two things changing, then you can't say for sure. So these are all meant to be like, if only the sample size increases, if only the sample size decreases. And they can also be written backwards. Like a question could say, if the confidence interval narrows, which of the following is true? And you would have to know that its sample size increases.
Okay.
But it could also be that the confidence level changed as well. Like there's multiple ways to do it is the point.
Okay.
Any questions on that or anything
No,
you'd
it
like
makes sense.
to? Okay. It doesn't look like they're talking about standard deviation. That also affects the width of the confidence interval, but we'll exclude that for now. Okay. So what other questions can we go through on this one?
I think 477 kind of relates to what we're talking about.
All right, let me get that one. I don't see that one. Oh, there it is. Okay, yes. It's exactly, that is exactly what we've been talking about. So this is exactly what we just said. As the confidence level increases, the width also increases. As confidence level decreases, the width, I'm sorry, let me make sure I got this right. Width of the confidence interval. Sorry, hang on just a second here. Let me read this one more time. Confidence level and the width of the confidence interval. Yeah, okay. Yes, this is correct. This is exactly what we wrote in question 471.
Okay.
The same idea. If it hasn't been stated yet in this class, like one of the really important takeaways is that every statistic or anything you tell someone really is a condition of confidence. It's like, I believe the mean to be 10 and I'm confident with 99% probability. Like, we don't walk around doing that, but that is what this class is kind of getting you to see, is that there's no certainty. It's just that you feel pretty sure about things because you're very confident in the answer.
Yeah.
But there's always a small doubt. And we see that at election time. We see that in other things,
Mhm.
weather predictions, things like that. Where should we go from here?
Could we do 478 and 479?
Yes. All right, let's grab 478. All right, assume that population A has substantially less variability than population B. Okay, so variability refers to standard deviation. Also, kind of the word variance, standard deviation, variance are very much related. Okay, so here's how the variability, as the variability increases, the width or the confidence interval becomes wider. And the reason is because when there's more variability, there's more uncertainty. You're like, wow, that's a big, there's a wide range of numbers that this value could take on. And like, I don't know, like if you ever get your school cafeteria, but it's like you go in there and someone gets like or maybe Chipotle is a better example. Like, they got all the meat on their bowl and I got a little bit of meat, and you're like, wait, that's not right. So the more variability it is, the wider the confidence interval, because it has to account for those variations.
Okay.
And that's the variability directly, because as one goes up, the other goes up. Similarly, if there's less variability, they just use the Chipotle again. They're always using the same spoon when they spoon in your food. So when they get you a scoop of rice, it's probably the same bowl to bowl or burrito to burrito. The confidence interval gets narrower because there's more predictability in what's going on here.
Mhm.
And there is a distinction between confidence and predictability, but I'm kind of using them interchangeably for this discussion. But hopefully you can see that the variability or the standard deviation, the more there is, the wider the interval has to be to contain all those values. But if you're pretty sure less variance, then it's going to be narrower.
Okay.
So in terms of the answer, the one that's less variable is going to be narrower. So in this case, A should be narrower than B. We got to find that answer. It's kind of that SAT, ACT thing where you got to like, well, I know the answer, but which one is it? Looks like it's C.
Okay.
All right, we'll move on to 479.
Okay.
Do you think you're going to get this style of question on your test? These multiple choice type, standardized test type?
I'm not sure if it's going to be, I don't think it's multiple choice. I'm just gonna have to provide an answer for it.
Okay. Yeah, the reason I ask is whenever you see one of these, which of the following, you just go right to the answers because the rest of it's not all that helpful at the moment. That's one of those strategies we've talked about. So which of the following is true? A confidence level of 80% will produce a wider than 90%. What say you? Is that true or false?
A confidence level of 80% would produce a wider interval compared.
So go back in your notes and look at 477. It's related to 477 if you've got them down.
Then I don't think it's true because the 90% would be
That's right.
bigger because both increase.
That's right. So letter B is the one where it tells it to you correctly. 80% will produce a narrower confidence interval. You got to be careful though, because there's this E down here which says B and E. So a sample of 300 students will produce a narrower confidence interval than a sample of 150 students. So C is asking you to look back at your notes on sample size. What does sample size do to the confidence interval? Does more students make it narrower, like it's saying? That's what this is saying. More students makes it narrower. So if you go
When
back
this
up,
when the sample increases, confidence is more narrow.
yes. So this is also true. So correct answer is E, which we might not, we might have thought, oh, B, go with B.
Okay.
All right, 480, do we need to do 480, 481?
Could we do 481?
Yes. Let's snip in. Okay, a random sample of 100 people taken from which of the following populations will yield the widest confidence interval for the mean income? So what I take that to mean, what, well, be careful here. So if I sample 100 swimmers at a swim meet, is that even reasonable? Are there 100 people at a swim meet? A big one, maybe?
Yeah.
And you all do like the 200-meter something? Not sure, forgive me. Like, are your times pretty close together for everyone who does a 200-meter? Roughly, like,
Yeah.
okay. So what would a 200-meter time, average time be for good swimmers like yourself and other people like you?
An average time for 200-meter, I would say, um, 2 minutes, 15 seconds.
Okay, so we'll say 135 seconds. Does that sound okay?
Yeah.
All right. Now, 200 meters is like you start at one end, you go to the other, then you come back, then you go back, and then you go back. Is that right? 50-meter pool. Is that normal?
Yeah.
Okay. So now let's just say you sample 100 people that are at the local swimming pool.
Mhm.
What do you think the average time would be?
That are not swimmers?
They're just people that are like, yeah, we're doing a thing today. We'll get you a gift card if you can swim 200 meters. I'll just make a number. Let's say it's 235 seconds.
Yeah.
It would obviously be a lot more, right?
Mhm.
But remember we were looking at some plots of dot plots. You're
Mhm.
at 135, there's going to be a lot of data like centered around this point. Whereas at the 235, you might get people that can do it over here at 135, you know, people that take a lot longer, which
Mhm.
is more spread out.
The bottom one, this
The
one.
bottom, yeah. And we just said in the previous problem, sorry, 2 problems ago, we said that the more variability there is, the more it increases the confidence interval.
Mhm.
So if we want the widest confidence interval, we're looking for a sample that's going to yield a lot of different results. So when you're looking at these answers, you're trying to decide which of these samples is like the broadest, or in other words, the least specific.
Oh, the least specific.
And I'm not saying it's easy. I think this is actually pretty hard to do. I'm not even sure I could tell you the right answer, but I think there's a few we could say are not. Um, like A is out. A is very specific. They're workers in Denver.
I would say B or C.
Okay. Yeah. One of the things about C is that it includes people that have like a job that you would have in high school, so it might be very hourly. 22 could be a young professional. I'm not sure.
Mhm.
Um, Compared to like E though, like E and B. Um, E is more specific, so that's why we would say E is out. 22 to 30, you got a lot of range. Like people just
Yeah.
coming out of school versus those that have got 7, 8 years experience, you would think would be a little bit more varied than 16 to 22. And
Yeah.
then but letter D is more than the US workers though. What does letter D include? What kind of workers?
Who live in North America?
North America, so Canada, US, and Mexico. You know, we bring some of our stereotypes in this. We think that people from Mexico somewhat make less money. Don't know if it's true or not, but that's the perception than compared to the US and Canada. So D might have the most variability
Mhm.
because it includes not just US workers, but also Canada and Mexico, which might run it. I'm not sure. I don't think this is a great question, but it's what we've got in front of us. So I probably would tell you it's D. I'm not 100% confident in that. I would say I'm like 95% confident in that answer.
Okay.
But the takeaway for you should be try to draw an analogy to something you already know.
Okay.
Like you can say it's swimmers 22 to 30 who live in Tucson, all US swimmers, if that's a good one for you to. And you can change mean income to mean, swim time. That may help you with this.
Okay.
Okay, so definitely got until 9 and potentially beyond. What's the goal here? What are you still trying to get through?
It's just this paper. I was kind of looking at 473.
Okay. Okay, so you need a picture for this. There's the center line, which is usually the mean. There's the confidence interval. Okay, so this whole thing is the confidence interval.
Mhm.
But 1/2 of it is considered the margin of error. So both sides of it are the margin of error. So to answer this question, which we will do, you have to have a clear picture there that the confidence interval is centered at the mean, or the proportion in other examples and other things in other examples, but there's some sort of centered place. But left is margin of error, right is margin of error. So in this problem, they're sampling 100 American car owners, and they're saying the 95% confidence interval is from 60 to 70%. So what they're saying is the left side of your confidence interval is 60%, and the right side of your confidence interval is 70%. That's your confidence interval.
Okay.
What is the center? What is the average between those two?
65.
65%. So the margin of error is 5%. And sometimes ME is used for margin of error.
Okay.
Similarly over here. Okay, so we got some options here. We could stop here. I can put you on pause and I don't think the call will take more than 10 minutes if the person answers. It's just a new customer. But what would you like to do? Do you have some more questions, or do you want us to stop here?
This is all I have, and the other two questions are pretty similar to what we've been doing, so I think I'm actually good.
Excellent. Before you go, real quick, I am doing an SAT/ACT prep class. It's kind of
Mhm.
similar to what we've been doing. It's a little more structured with like test taking strategies and content areas. If you were interested, I was going to do it on a Saturday. Is 10 a.m. or 12 p.m. a better time for you for class?
I would say 10 a.m.
10 a.m. You're at 10 a.m. Okay, I got you down. This Saturday is just like a preview, so I'll be putting something together for that. If you
Okay.
can make it, great. Thank you again. Do you know if you want to make this a regular time, or are you still figuring that out for yourself?
Um, I'm trying to figure it out as of right now.
Okay. All right. Sounds good. Okay. Well, thank you for letting me help you this evening. I will send over the notes here shortly, and I'll see you next time.
Okay, thank you so much.
Have a great night. Bye now.
Bye.